So I unintentionally left you in a little bit of a broken state. As you've probably seen, and as you can see here, our player is disappearing beneath floor tiles. It's appearing on top of wall tiles. So let's go ahead and fix my mistakes. We're going to go ahead and enable Y-sort on the tile map node. We're going to bump the z-index of structures up to 1. And then we're also going to bump our player index up to 1. We've got a couple adjustments left. As you can see here, I'm hidden behind the floor now. But that's good. That means our Y-sort's working and everything is on the same layer. What we need to do is go into our tile set and then adjust our Y-sort origin on the tiles themselves. We're going to set the sort origin at the bottom of the tile. But as you can see, we're still disappearing underneath the floor. And that is because we want to set that at the top. That way we are never sorting with it and we are always on top or in front of that element. This was a good learning and, of course, now a teaching moment. So why didn't this work? So before, when we had Y-sort disabled on our tile map, that effectively registered that as the new root node for anything Y-sort underneath it. So structures was sorting, but it was sorting with respect to tile map instead of with respect to our root node, which is where our player is being sorted. I've just disabled Y-sort on the tile map layer, and you can see that our player gets hidden when it goes above the Y-sort and is then shown again once it's below that Y-sort origin. We'll do some quick cleanup to align with the Godot naming standards. So we're going to be renaming the nodes to be Pascal case. And when you're renaming these unique nodes, it should prompt you, ask if you want to revoke the unique name. If you don't do this, the reference will still be to the old lowercase, in this case, dirt. And of course, make sure you make the node unique again. We'll also need to update some code for this, and as well as a lot of these other tiles. And this is kind of the pitfall of accessing things by node name, so we'll try to avoid that going forward. Control-Shift-F will bring up the Find in All Files. Searching for our player tag, looks like we didn't have any references for that. And then we've only got the one reference for dirt. Make sure to make that capital, looks like I've already done it. And then we've got some other things like tile overlay. So it's not just the unique nodes that need to be updated. All right, it's time to implement some crops. The first thing we're gonna need is some form of a day-night cycle. So we're gonna go ahead and create our world clock. We're gonna add a new child node to our root, and it's gonna be a timer node. Rename it world clock, and let's create a new script. No surprises here, our class name is going to be world clock. And we're just gonna add a couple parameters to help us configure our clock speed. First one is gonna be our clock hour length. It can be any number 1 to 200, going in steps of 10. And then we've got an integer for time scale, and that's just gonna help us speed up or slow things down without having to modify our hour length or mess anything up. The group is optional, it just gives a nice little fold out in the inspector view. And obviously we will need to declare a variable for hours and days. We'll define a couple of signals we're gonna emit. One is clock progress, that'll go every hour. And then we've got a new day signal, which we'll fire off once a day. Let's take a look at our timer docs and we'll see what we're gonna leverage to implement our day cycle. Timers will be on an interval unless you specify one shot, so we'll just need to call start, and then we're gonna listen for our timeout signal. And when that triggers, we'll know to advance the clock. All we need to do is call start in our ready function and then pass it the interval duration, which is going to be our hour length divided by the time scale. We'll go ahead and stub out our signal handler for the timeout. And then we'll connect our timeout in our ready function. Since we're just measuring by hour, the math and implementation here is going to be pretty simple. We'll add 1 to our hour each time, and then we'll check if our hour is 24, that is the end of the day. So we're going to go ahead and reset our hour to 0 and then increment our day by 1. We'll make sure to fire off our new day signal and also the clock progress outside of our if statement. So we aren't passing any arguments when we're emitting our new day signal, but the clock progress signal, we're going to want to emit the day and hour so we can update things more granularly like the clock display. Which is a great segue to creating our interface, and we're going to start with our world clock. To To keep our interface in frame, we're going to need to add things as a child node of our camera. So we're just going to add a label as a child of the camera 2D. You don't need to worry about this text right now. Just go ahead and style the font however you'd like. I'm not doing anything in particular, just making it visible and demonstrating. And like all nodes in the tree, everything respects z-index. So we're going to have to bump up our z-index something high, as the interface is almost always going to be on top. And it looks like our interface is tracking as expected. But we've got a little blur going on, so let's fix that. We're going to bump up the oversampling on our font, and that will give it that crisp, pixel-perfect edge. The whole thing's a little chunky right now, so we're going to select the scale tool and adjust it. You can either select it in the toolbar or hit S. And don't do this, make sure you hold Shift, and that will allow you to adjust the entire thing and to keep the aspect ratio. I sneakily renamed it to Clock GUI, and we're going to go ahead and attach a new script to this. We'll define a reference to our world clock node, and we need to make that unique. And we'll go ahead and define a variable for the template string that I had put in the text directly. And the export multi-line is just going to give us a text area in the inspector, so it gives us an easier editing experience for multi-lines. This script's pretty basic. We're just going to listen for our clock progress signal from our world clock. And then each time we get an update, we're going to update the label. And we'll go ahead and set the default text to day 0, hour 0. That way there's something to display when we're editing. All right, everything appears to be working, which means we can move on to crop life cycles. But before we get there, we're gonna have to define some auto loads, which are global scripts that we can access from any other script. To keep things organized, we'll create a scripts folder, and then within that scripts folder, a new script called global. Obviously, I moved all of our existing scripts into this folder as well. We'll go ahead and open the global script, clear out the default template if there is one, and then we're going to define an enum for our growth phases. This asset pack has 4 sprites for each crop, so we're going to have a germinating stage, a budding stage, a flowering stage, and then a stage we're just going to call mature. We're also going to define some global resources, one of them being the mouse cursor. So in your project settings, you can set the default mouse cursor. This mouse pack is from Kenny, and like all the assets we use, the links are going to be available down in the description. And this video is brought to us by Gadget. It's my new project. If you're looking for plugins, this is an easy way to find them. Everything is sorted by category, and you can go ahead and filter by Godot version, but this is going to give you some extra information the Godot asset marketplace is lacking, simply by pulling some GitHub information like the popularity of the repo and of course all the README information. You can find a link to the repo and the download URL both on the website. Choose whichever cursor you'd like. I just went with the hand point, and make sure it's the outline, otherwise it'll get lost in the sauce. We're going to preload a couple of cursors here. That way we can have a different cursor when we hover our crops and then switch back to the default. So we'll just define a constant resources, give it a key of cursor, default, and harvest. And then we call preload, which will preload those and cache those assets so we can access them when we need them. Now this script isn't doing anything yet. We need to open the project settings once again. We're going to navigate to the globals tab, the auto load sub tab, and we are going to load our new global script. You can see the node name is auto populated for you based off the script name. You can change it if you want. We're just going to leave it as global. And now that is registered with that global name and is accessible in all of our other scripts. While we're on the topic of auto loads, let's go ahead and address an issue that happens with keyboard, mouse, and controllers or gamepads. So found in the Godot documentation, there is a blurb about window focus that effectively states that controllers send input to every window all the time, no matter what's focused. So unless you're going to try to implement some kind of a split screen, you're going to want to implement this focus auto load class in order to ignore those events. Luckily, we haven't gotten too far, so we won't have to update too many scripts. But let's go ahead and search for all the places we're using input for the isActionPressed and the event isActionPressed. Looks like most of our input handling is on our player controller, which makes sense. But right at the top of our results is input get vector, which we're going to have to implement. It was not in the example. Make sure you don't accidentally update the focus script itself and replace that. The only other script we'll need to update right now is door. We've got a couple things left, an update that neither I or the IDE have realized yet, but first let's go ahead and implement get vector on our focus class. So instead of taking one action, we're going to end up taking all actions for the movement here for each direction, left, right, up and down. Update our return type to a vector2. We're going to call the input get vector function, and then if we have no focus, we're just going to return vector0. And those sneaky little names get right past you when the IDE isn't there holding your hand. So I've forgotten to put input on the other methods, and I have forgotten to add it to our new method. So we're going to go ahead and add the input underscore prefix to get vector. And we need to go ahead and update all our other method calls and add the correct prefix to those. And then we got to update our door class as well. And our isOpen variable here is camel case. That is a holdover from me being a TypeScript dev. So we're going to go ahead and update that to be more consistent with Godot. We'll go ahead and test that and make sure none of our functionality broke and everything is working as expected. And looks like all of our movements, directions, and animations are registering. So how do we define these dynamic items? And the answer in Godot is to create resources. So we're going to create a new script here. It's going to inherit resource, and we're going to call this mapped texture. We'll go ahead and open our new mapped texture script, assign it a class name of mapped texture, and the first reference we're going to need is to our texture 2D resource. And I like the way Sprite Frames handles this with the regions. So we're going to define the number of horizontal frames, number of vertical frames, and then the current frame in those dimensions. We're going to add the export group annotation. That's just going to help group things up in the inspector, make it a little nicer for us to use. And finally, we'll define our clip texture method, and this is going to return just that region of our overall texture 2D resource. So we're just calculating the texture width and height based off of the number of frames we have and the total height of the resource. And using the frame position and the texture size, we can find the texture's position, get the texture's region, and then from there we can create a new atlas texture, which is just a small snapshot of an overall atlas map. Assign its atlas property to our original resource, and then define the region which we calculated above. Now that we've got a strategy to load our individual textures, we can go ahead and define the rest of our scripts, starting with our crop resource. So our class name for this resource is crop, and then we'll want to export a variable to keep track of our growth phase, setting it to the default of germinating as it's the first growth phase. And then we're going to go ahead and define the duration for each of these growth phases. Here it's defined with a minimum of 1/2 day, a maximum of 4 days, with half-day steps in between. And then rinse repeat for budding, flowering, and the maturation phase. And we could just simply look at the growth phase on our crop to determine if it's harvestable, but it's easier to go ahead and define a function that way. All of the complexity is contained within crop, and we only need to know if it's harvestable, not about any specific growth phase. And following that same train of thought, we're going to implement the advancement of growth phases within crop as well to avoid the same issues. And I've added an assert function here. What it does is it will evaluate this expression, and if it fails, it will create a debug breakpoint and pause the execution of the game. These are typically used in places where the assertion is expected to always be true. So if a fundamental expectation or assumption is incorrect, you can address it quickly. And the last piece of our crop puzzle is going to be defining a little helper texture, and this is just going to be defined with a getter, and it's going to be calling our clip texture for us, just as some syntactic sugar to make things easier down the line. It's time to create the node for our plot. So we're going to right-click our structures node, add a child node of a static body 2D. We'll go ahead and rename this to plot, and we'll give it the collision shape that it so desperately desires. and we'll just populate it with a default rectangular shape. And most importantly, we'll need our Sprite 2D node to display the actual texture. And then I'm just going to reposition the plot node to be on the grass outside here, and we'll place some dirt tiles around it just for the aesthetics. With our node set up, we can create our plot script. So we're going to attach a script, extend static body 2D. We'll give our script a class name of plot, define a reference to our sprite, and also define a reference to our crop. And our crop is just a data container, but it's a resource, so it's got a few extra bells and whistles like signals. However, resources cannot access nodes directly. So in our plot, in our ready function, we will access our world clock. We'll go ahead and connect to our clock progress signal. And the only reason for using this signal as opposed to new day is that we've defined our crops to have half-day durations. We'll define our handle hourly growth signal handler. And this signal emits our day and hour, so we just need to check if our hour is half the day. If it is, we're going to advance our growth phase, and we're going to set our sprite texture equal to our crop texture. But our sprite variable isn't referencing anything yet, so we need to assign our sprite variable to the sprite within our plot. And this is the explicit way of defining your dependencies instead of relying on the name of the node by node path, or by unique node. Either way, they're referenced by name, which is their pitfall, and this way we're referencing by UID. So it's a much more reliable, unchanging source. And as you can see, Godot recognizes our new resources, which makes them easy to load, easy to manage. And we're gonna need some way to determine if our crops are harvestable. So if we enable pickable under the input section in the inspector, that will allow us to tie into the mouse enter and mouse exit events. From here, all we have to do is assign the correct cursor for the correct states. So if we are harvestable on enter, go ahead and set it to our global resources cursor for harvest, and then we exit, set it back to our default. In order to handle the mouse down event, we're going to tie into the input event function. And using our new focus auto load, we're going to call event is action pressed on the select event. And if our crop is harvestable, for now we'll just print harvest. And in the near future, we're going to be destroying this object. So we will need to reset our cursor to default as the mouse shape exit will no longer be listening. Make sure you've got the select input action defined. And we want our sprite texture to show up immediately, so we'll go ahead and set that in our ready function. And there's one quick fix we need to make. I won't tell you how I know, but texture width and height got a little mixed around here, so just update the width and height. And let's see if the fruits of our labor have paid off. So we should see the crop grow every 12 hours. And it appears we've got some adjustments to do with the crop sprite as it's a little offset. All right, the final countdown. Once we hit hour 12, we should expect our crop to enter the mature phase, and we want to make sure that our cursor is updating as expected. So our crop is grown. Let's hover over it. We've got a little hand, and I'll click it once. Let's see what happens. Perfect. It has returned to our default cursor. And if we go peek at our output, we should see our harvest has logged. And we're doing a lot of legwork in this part, but it's got to be done. We've got a couple more resources to define. We'll start with our item resource, and this is going to be what we use for our seeds to plant the crop, and then obviously the crop that we get from our harvest. We'll define our class name of item. And for now, this is going to be a pretty thin resource. We're just going to give it a name. We're going to supply it with a mapped texture resource, and then we'll define our texture getter, but this time we are just going to rely on whatever the texture resource frame value is. And of course, we will need somewhere to place the items, so the next resource we'll create is our inventory resource. And at the moment, we will just define the max capacity of our inventory. We will define a items dictionary. And the dictionary just allows us to define a slot, even if they're empty for each inventory spot. It's easier than an array. And we'll define two signals for items being added and removed. And this is one of the nice things about resources. We can access signals. And then on initialization, we are going to iterate from 0 to our max capacity, and set the key as our index and the value as null. Of course, we'll need an add and remove function. If the value we received is an item, we will go ahead and find the first empty spot, and then we will populate that and emit our signal. And we'll do the inverse for remove item, where we find the item and set that back to null. And of course, these assertions are only checking at development time. The if statements are what's going to handle the code in the wild. Next, we need to create an inventory on our player. So we'll export a variable for inventory. And we'll go ahead and create the resource to populate that variable. And if you expand our new resource, you can see our max capacity is 10, but our dictionary size is still 0. So why did our init function not work? Go ahead and clear out the inventory resource we just created. And then we're going to navigate back to our inventory resource, and we need to add the tool annotation at the very top. And this will allow our resource to run code in the editor. So now when we initialize our inventory, as you can see, we've populated our dictionary with indexes and our null values. We're safe for now with our implementation, but tool will allow you to run editor code. That means these scripts could be hybrid, so if you're running both code meant for only the editor or only runtime, you need to specify that in your scripts. And I'm going to save this as a project level resource under the name player inventory. So now we've got our world clock, we have our farm plot, we have our crop, item, and inventory. Next, we'll continue tying it together by harvesting our crop and creating our loot items. There was a lot to do here. It was hard to find a stopping point, but due to that, I've made some progress on part 4, so expect that soon. Thanks for watching, and if you'd like to follow along for the rest of the series, don't forget to hit that subscribe button.